we are going to learn to solve a system of equations. This is a basic one, but hopefully you understand how substitution works. So let's solve this system of equations. And there it is again. X minus 1 equals 1 forms a line, and x plus 1 equals negative 1 forms a line. Let's discover where they meet. So it's going to be important to isolate a variable in one of the equations first. I picked the bottom equation. It's got an easy variable to isolate. There's no coefficient on it. So I'm going to isolate the y. Simply subtract x from both sides of the equation. Once that's done, I know that the y equals negative 1 minus x. This means we can substitute negative 1 minus x for y in the other equation. Just like that. So I change the y to negative 1 minus x. Once I've done that, I have to solve for x, and I'll know half of my coordinate. So I combine the like terms, I get a simple two-step equation. 2x plus 1 equals 1, so I'll have to subtract 1 from both sides. I'm left with 2x equals 0. So I'll have to divide both sides of the equation by 2 to completely isolate x and discover that x equals 0. All we need now is to solve for y, and we'll have both parts of the coordinate. So substitute 0 for x into either equation or into both of the equations. I've done that, and I discovered on the right equation that I get y equals negative 1. It's one extra step on the left equation, but either way I get negative 1 for y, so my final answer where they meet is at 0, negative 1. Now I just want to prove and check and make sure that that is exactly right. So I'll put my 0 and my negative 1 in for x and y, and it worked in the top equation. I'll substitute 0 and negative 1 into the bottom equation as well, and of course I also get a true statement proving that that coordinate is a solution of both equations, and we know that that is exactly where those two lines intersect. I appreciate you listening so carefully. Please have a good day.